Alright guys, Marina here with another algebra video. This video is for tomorrow, Tuesday, March 24th. We're going to do our third way of factoring. So far we have, from Friday, our first way of factoring, which was called greatest common factor, or GCF. Our second way of factoring, which we did today, which is called the difference of two perfect squares, or dots. And then our third way of factoring, which I'm going to show you in a moment. The do now here, which is a review of a couple of the ways that we've been doing factoring. Let's take a look at number one, 4x squared plus 36y. So right now you only know two ways of factoring, greatest common factor as well as dots. And I noticed that 4x squared and 36y, they do have something in common. So you're going to go ahead and factor this with the greatest common factor. So let's start with the number. 4 and 36, they have a 4 in common. X squared, y, they don't have anything in common. So the GCF of this polynomial is just 4. So divide both of these by the GCF of 4. 4x squared divided by 4 is just x squared. And 36 divided by 4 is 9. This would be positive 9, and bring down the y. And put the GCF of 4 in front. So after we factor that, we get 4 parentheses x squared plus 9y. Taking a look here at number 2, I notice that those two terms do not have anything in common. So we can't factor that with the greatest common factor, but we can factor that with the difference of two perfect squares, which we did today, or yesterday if you're watching this video on Tuesday. X squared is a perfect square because it's x times x. 36 a perfect square because it's 6 times 6, and 1 gets plus and 1 gets minus. Right? You can also write your answer as x minus 6 times x plus 6. That's the same thing. Doesn't matter which order you put it in. Number 3, this one's a little tricky. At first glance, you might notice that both of those terms are perfect squares. 36, 49, those are perfect squares. So is y squared and y to the 8th power. However, well, actually no, I was just going to say that they have something in common, but they don't. So it's not greatest common factor. It's the difference of two perfect squares. 36y squared is 6y times 6y. Put a plus and a minus. And 49x to the 8th is 7y to the 4th. And 7y to the 4th. Moving here to number 4, before we start the new method, 3ab minus a. If you're looking at that and noticing that they both have a in common, that's great. That means we're going to use the GCF method. And a is the only thing they have in common, so divide both of them by a. 3ab divided by a, the a's will cancel out, leaving you with 3b minus a divided by a is 1. Put that in parentheses and put the GCF in front. So that is a summary of the two methods of factoring that we've done so far. Again, I have to give you guys a graded assignment at some point this week. So I'm going to wait and see how you guys do with today's lesson, and then I'm either going to put up a Delta Math or a quizzes for you guys to work on that goes over all three of these methods, GCF, dots, and AM. So today's lesson actually starts right here. How do we factor trinomials? If you take a look at number 1, x squared plus 8x plus 7. So again, let's go through these methods that we have. The first method that I taught you, GCF. So does x squared plus 8x plus 7 have anything in common? X squared plus 8x plus 7. I see that x squared and 8x have x in common, and 7 doesn't have an x, so I can't say that. I don't see anything in common between all three of those terms, so it's not GCF. Now we come here to the dots method. Is this the difference of two perfect squares? Well, no. It's a trinomial. So this is the new method today called AM. What you do is you go to the middle and you put an A, and you go to the end and put an M. And AM stands for add and multiply. The setup for this is going to look familiar. Draw two parentheses, just like we did with the dots method. And since this first piece is x squared, you're going to go x times x. Now, this is where it gets a little bit tricky. This is where you got to think a little bit and know your multiplication tables. I got to put numbers in these parentheses. And you're not just going to pick any numbers. These numbers have to multiply to positive 7. So what numbers multiply to positive 7? Well, that can be 1 times 7. That can also be negative 1 times negative 7. And that's all I can think of. Now, how am I supposed to know which numbers to use? You also need to look here. Positive 8. And you see how there's a little a on top of that? Which of these pairs of numbers over here multiply to positive 7, but also add up to positive 8? Well, both of these sets, 1 times 7, negative 1 times negative 7, they both multiply to positive 7. But the only one that actually adds up to positive 8 is the 1 and the 7. Those are both positive, so one parenthesis is going to get plus 1. The other parenthesis is going to get plus 7. You even check your answer by using the box method. You could do x plus 1, and x plus 7, and start multiplying. You'll notice here you have like terms. So when it's all said and done, this would combine back together to give you x squared plus 8x plus 7. And that's how you can check your answer. So I'm going to fill that answer in over here. This was x plus 1, x plus 7. I'm going to do a couple more of these with you guys, and I'll leave you to practice the rest. Okay, x squared plus 11x plus 30. Again, there's nothing in common between all three of those terms. It's not the difference of two perfect squares, so this is going to be the AM method. Two parentheses, put in A, put in M. The first term is x squared, x times x. Now I got to think of numbers that multiply to positive 30. Well, I could know, let's see, 10 times 3, 5 times 6, 15 times 2. However, I want the numbers to also add up. That's the important part here. Not just picking any two random numbers that multiply to 30. They also have to have a sum or add to 11. So I'm looking at positive 5 and positive 6. So the solution is x plus 5 times x plus 6. Let's do two more. Number 3. X squared is x times x, AM. Numbers that multiply to 12. Let's see. 4 times 3, 6 times 2. You can even go 1 times 12. But what do I want the numbers to add up to? Negative 8. None of those numbers add up to negative 8. That's because we didn't realize that I can also have two numbers multiply to be positive 12, like negative 4 times negative 3, negative 6 times negative 2, negative 1 times negative 12. So which one of these combinations are numbers that multiply to positive 12? Well, they all do, but also add up to negative 8. And if you're looking at this one, that's correct. Negative 6 and negative 2 multiply to positive 12 and also add up to negative 8. Last one I'll do with you before I leave and let you guys work on this on your own. M squared, m times m. Here I want numbers to multiply to negative 90. So that's like 10 times negative 9. You can switch that and do negative 10 times positive 9. You can even think of that as 45 times negative 2, negative 45 times positive 2. There's a lot of ways to multiply to negative 90, but I want them to add up to, I don't want them to add up to positive m. That doesn't make any sense. You want them to add up to positive 1. There's a 1 there. So the two numbers that multiply to negative 90 and also add up to positive 1 would be 10 and negative 9. So I'm going to put a plus 10 in one parentheses and a negative 9 in the other. And again, you can use the box method to check your answer, but I'm not going to do that here. So you guys can practice the rest of these on your own. I'll be in the Google Hangout answering questions from 12 to 1:30, and I'll let you guys know about your graded assignment whenever I decide what that's going to be. All right, guys.